Bugatti Chiron Super Sport 300 Plus. In August 2019, on a closed section of Volkswagen's test track in Erlesien, Germany, a modified Bugatti Chiron driven by factory driver Andy Wallace crossed 490 km/h for the first time in the history of production car manufacturing. The number had been discussed, theorized, and chased for decades by hypercar manufacturers who kept arriving at the same conclusion. The tires, the aerodynamics, and the power required to sustain that speed simultaneously in a road-legal vehicle were beyond what was achievable. Bugatti achieved it with a quad-turbocharged 8.0 LW16 engine, producing 1,578 horsepower. A body lengthened and reshaped specifically for low drag at extreme speed, and a set of tires that Michelin spent years developing because no existing tire could survive the centrifugal forces generated at that velocity. The record came with an asterisk. The car was a prototype rather than a fully production-ready unit, and Bugatti elected to limit the road version to 440 km/h out of tire safety considerations. That asterisk did not diminish what happened on that track. The 490 km/h barrier fell, and the machine that broke it was as close to a production car as anything that has ever done so. Before Bugatti arrived with its Volkswagen Group resources, the record belonged to a company that had no business being anywhere near it. Koenigsegg Agera RS. Before the Chiron arrived with its corporate resources and Volkswagen Group engineering budget, a small Swedish manufacturer with a factory employing fewer than 100 people held the production car speed record. The Koenigsegg Agera RS reached 457.49 km/h on a closed public highway in Nevada in November 2017. Not on a private test track with optimal conditions, but on a public road temporarily closed for the attempt. It set 4 separate world records in a single day, including fastest 0 to 400 km/h time and fastest 400 to 0 km/h stopping distance. The Agera RS produces 1,160 horsepower from a twin-turbocharged 5.0 LV8 engine that Koenigsegg designed and built entirely in-house. No borrowed architecture, no supplier engines, every component conceived and manufactured within the same facility where the car was assembled. That the record was set on a public road rather than a purpose-built test track made it simultaneously more impressive and more difficult to replicate. The surface conditions, the altitude, and the wind were entirely outside anyone's control, and the car still performed anyway. The Agera RS set its record cleanly. The next car to challenge it did not, and the story of that attempt is more interesting than the record itself. SSC Tuatara. The SSC Tuatara's speed record is the most controversial in automotive history, and the story behind that controversy is more interesting than any straightforward record would have been. In October 2020, SSC claimed a two-way average speed of 508.73 km/h on a closed Nevada highway, which would have made it the first production car to break 500 km/h and the fastest production car ever recorded by a significant margin. The claim was immediately disputed. Video analysis by independent engineers showed the speed data appeared inconsistent with the footage. GPS tracking data was questioned. SSC conducted a second attempt in January 2021 and recorded 455 km/h, dramatically lower than the original claim and below the Koenigsegg record the first run was supposed to have shattered. The original 508 km/h claim was withdrawn. What remains is a car producing 1,750 horsepower from a twin-turbocharged 5.9 LV8 that is genuinely capable of extraordinary speed, just not the extraordinary speed its manufacturer initially claimed. The Tuatara is fast. The question of exactly how fast remains in the most technical sense. Open-dot combustion engines defined the top speed conversation for a century. Then electric motors arrived and rewrote what acceleration could mean entirely. Rimac Nevera. The Rimac Nevera holds the production car acceleration record, and the number that defines it is 1.74 seconds, the time it takes to reach 97 km/h from a standing start. That figure requires context to land properly. A professional sprinter covers approximately 12 minutes in 1.74 seconds. The Nevera covers 23 m and reaches 97 km/h in the same time. It produces 1,914 horsepower from 4 electric motors, 1 per wheel, with torquey vectoring that distributes power between wheels individually hundreds of times per second, to maintain traction at accelerations that should theoretically overwhelm any tire. The top speed of 412 km per hour is almost secondary to what the acceleration figures represent, a fundamental recalibration of what is physically possible in a road-legal vehicle. Mate Rimac founded his company in a garage in Croatia, building battery systems for converted electric cars. The Nevera is the machine that company grew into a production hypercar that holds more performance records than any other electric vehicle ever built, and challenged the assumption that internal combustion engines would always define the upper limit of automotive performance. The Nevera R, unveiled in 2024, has since broken every record the original Nevera set, reaching 97 km/h in 1.66 seconds and a top speed of 431 km/h, proving that the original was not the ceiling, but the starting point. If the Nevera redefined acceleration, the next machine arrived from an entirely unexpected direction and redefined top speed. Yangwang U9 Extreme. China entered the hypercar conversation in September 2025 and immediately went to the front of it. The Yangwang U9 Extreme, built by BYD under its luxury Yangwang brand, achieved a verified top speed of 496.22 km per hour at the ATP Automotive Testing Papenburg facility in Germany, dethroning the Bugatti Chiron Super Sport 300 Plus as the fastest production car ever recorded. It produces 2,978 horsepower from 4 electric motors, each capable of spinning at 30,000 revolutions per minute, running on a 1200-volt electrical architecture that is the highest voltage system ever fitted to a production vehicle. Only 30 units will be built. The record carries a significant caveat. Guinness World Records requires a two-way average speed measured within 1 hour to validate a production car record, and the U9 Extreme's run was conducted in one direction only, which led to its exclusion from the official record books as of 2026. The speed was real. The record was not ratified. What the U9 Extreme represents, regardless of that asterisk, is the most dramatic single entry into the top speed conversation by any manufacturer in the history of the hypercar. A Chinese electric vehicle arriving with nearly 3,000 horsepower and immediately going faster than anything Europe had spent decades building. Some manufacturers chase records. The next three are chasing numbers that have never been achieved at all, speeds that exist so far only in calculations, simulations, and ambition. Koenigsegg Jesko Absolute. The Koenigsegg Jesko Absolute has never set a top speed record because it has never attempted one. What it has done is publish a calculated theoretical maximum of 531 km/h based on its aerodynamic drag coefficient, its power output, and the mathematical relationship between those figures at increasing speeds. A calculation that Koenigsegg's engineers are confident in, but that remains by definition unverified. It produces 1,600 horsepower on standard pump fuel and 1,800 horsepower on E85 from a twin-turbocharged 5.0 L V8 connected to a 9-speed transmission, with a shift time of under 20 milliseconds. The Absolute name refers specifically to the drag-optimized configuration. Lower downforce, cleaner aerodynamics, every body surface tuned for minimum resistance at maximum speed rather than the cornering grip that the standard Jesko prioritizes. Whether the theoretical 531 km/h is achievable in the real world depends on finding a stretch of road or test track long enough and smooth enough to reach that speed safely, which has so far not happened. The number exists on paper and in simulation. The car that could produce it exists in garages around the world. The record does not exist yet. Texas answered Sweden with a machine built not by engineers who inherited a hypercar tradition, but by a team that learned everything it knows by pushing existing engines past their limits. Hennessy Venom. John Hennessy has been building modified American muscle cars for 3 decades, taking factory vehicles and extracting performance figures their manufacturers never intended. The Venom F5 is the first ground-up original vehicle his company has designed rather than modified. A carbon fiber hypercar built in Sealy, Texas around a 6.6L twin-turbocharged V8 producing 1,817 horsepower that Hennessy calls the Fury engine. The target is 500 km/h. At the time of writing, that target has not been officially achieved in a verified two-way record attempt, though Hennessy has documented runs exceeding 450 km per hour during development testing. Only 24 units are being built. The Venom F5 represents the American answer to the European hypercar. Not built in a Swiss valley or Swedish factory, but in Texas by a team that learned everything it knows about extreme performance by taking existing engines and finding out exactly how much more they could do before they stopped working. The Fury engine is not borrowed from a manufacturer and not based on an existing design. It was built from scratch for one purpose: to push a car past 500 kilometers per hour. And whether it achieves that officially is a question that testing is still in the process of answering. And then there is the machine that has been claiming to exceed all of them for over a decade and has never fully proven it. Devil 16. The Devil 16 occupies a category that sits between hypercar and hoax, a machine from Dubai that has been claiming 5,000 horsepower and a theoretical top speed of 560 km/h since it first appeared at the Dubai Motor Show in 2013 and has been in various states of development, demonstration, and controversy ever since. The engine exists, a quad-turbocharged V16 producing figures that independent engineers have disputed and defended in roughly equal measure. A running prototype has been demonstrated. Whether the claimed performance figures are achievable in a vehicle that can also be driven on public roads, whether the production version will match the concept specifications, and whether the company has the manufacturing capability to deliver the units it has periodically claimed to be planning, none of these questions have been definitively answered. The Devil 16 is either the most extreme production hypercar ever conceived or the most sustained piece of automotive theater in history. The truth may be somewhere between those two positions, in the space where extraordinary ambition meets the practical difficulties of actually building what you have announced.